This session for the Amsterdam Hug is teaching AI to Terraform so that you don't have to. My name, in case you didn't see what I look like, you can see a picture of me there as well, but I wasn't sure what else to put in the template. My name's Sam McGeown, and I'm a developer advocate at Hashicorp. I have spent many years as a sort of VMware infrastructure engineer, and then a consultant, then as technical marketer, a product manager, and I most recently joined Hashicorp as a developer advocate. You could say that the common thread throughout all of my kind of long career has been the automation thread, and that's really something that I really enjoy doing is automating processes and making stuff easier for everyone. So that is who I am. I'm going to talk about MCP servers. So show of hands. The other thing I should warn you is that I do prefer a little bit of interaction. So if you've come to sort of have a snooze this afternoon, I'd prefer if you just talk to me. So I might ask you questions. But in a show of hands, how many people here are using an LLM, AI, ChatGPT in some context in their professional life today? Most people, right? So you've got that baseline experience, so we don't need to talk about that. How many people have used an MCP server with their AI chatbot? A handful. How many people are kind of familiar with what an MCP server is and does? Couple more. Okay, so I have 3 slides, and I promise it's just 3 slides, and then I will get to like doing some demos and having some fun. And I definitely need some interaction with you when we get to that bit. So, what are MCP servers? Okay, so basically, if you look at modelcontextprotocol.io, which is a lovely domain that is really easy to remember, they'll tell you that to think of MCP as a USB-C port for AI applications. So it's in effect a kind of pluggable universal interface to allow you to provide information and tools and context to your LLM. So your generically trained LLM is trained on a model of data set. And if you want to provide that LLM with some context, with maybe some information about what you want it to do, you've got really 2 options. The first one is that you can build your own model using all sorts of really advanced data science and training it on documentation sets and stuff that most of us probably don't really want to get in the weeds on. Or you can use an MCP server. And it was actually developed by Anthropic, who is, as most people are aware, one of the big players in the AI game at the moment. But it was created as a standard interface, so hence the USB kind of analogy for plugging in information into those models. It allows you to have this kind of structured and safe and extensible integration into your LLM model without you having to kind of write your own code and custom plugins and everything. So the idea being that when you run an MCP server, it's providing with interoperability, so allowing AI systems to connect to same tools with shared protocol, security, and this is a really interesting part of it because you can have your MCP server running in isolation, and your MCP server that's talking to a specific tool or endpoint can have its own security context, and that means that your LLM can't actually do anything without the MCP server being the gatekeeper for that. And that, when we come to talk a little bit later about like the different ways you can consume the MCP servers, that's one of the most critical kind of things that might push you to, say, hosting a service for an MCP server rather than having developers running MCP servers on your laptop. But I won't jump too far ahead there. So extensibility, we've kind of mentioned that a little bit. Basically, you can, if you're wanting to give specific functionality to your LLM, and then also consistency, so you can provide recipes and you can provide like a cookbook of processes that maybe 3 or 4 tasks strung together that you want to perform the same every single time you use your LLM to do something. So that's the kind of why of MCP servers. And I should say, right, my journey with MCP and learning all this stuff was very recent, and I'm learning in public. I'm speaking what I know now. Other people might correct me or have a better way of putting stuff. So take this as a starting point rather than the gospel of MCP servers. So how does the MCP server communicate? How does it work? Well, if you look at this diagram, on the left-hand side, you've got your MCP host or your client. Now, you can think of that as like your LLM, but you could also think of that like Visual Studio Code or Claude or any of the kind of vibe coding platforms, anything really that is invoking your LLM. It's going to communicate with an MCP server, which is the kind of binary that we're running that has all the instructions. And the way it communicates with that MCP server is over a kind of JSON RPC call. And typically, there are 2 supported ways for that to happen. The first one is the way that will happen if you're running your MCP server locally, say with Visual Studio Code, and you've got a Docker container running or some container running. It's going to use standard I/O, and it's going to do that JSON RPC call directly to that local container. The other one is a streamable HTTP, and that's when, for example, if you were to run it as a service somewhere else, it would communicate over that HTTP protocol using a series of posts. But what that does allow for you to do is to have, say, authentication, your own authentication layer in front of that HTTP service. So you could send an OAuth token to identify yourself. So the MCP host would identify itself to the MCP server in that initial communication. So that means that you could have an MCP server authorized for a certain group of people or a certain application, and that MCP server then has the context and permissions to go out to whatever it's talking to. But you also need to authenticate there. So it allows you to provide a layer of security over the top of that. And then what the MCP server provides are tools, resources, and prompts. And is the text readable? Yeah, just about. So tools are like executable functions, and I'm going to show you some of those in a minute. So actions that you can perform on whatever API your MCP server is fronting. Resources, basically a data source, something that you can query. And then prompts are those recipes where you want it to perform in a specific way or to perform actions in a series, as I mentioned, like those recipes before. So those are the 3 things that the MCP server is going to scope out to your LLM. And I promised you that it was only 3 slides, and that is the end of my 3rd slide. So what we're going to do now is jump over to a demo, and hopefully we can start having some fun with a little bit of code. And this is where I want some ideas and interaction for you, because the way it's going to work best is if I know nothing about it, and the interaction between MCP and LLM is the thing that actually we're proving that it's worked. I'm not pre-baking an idea into it or instructions. So, is that text big enough for everyone, or should I make it a little bit bigger? Can we read? Bigger? Bigger at the back. Let's try this. Is that better? Okay, cool. So, what do I have here? I have pre-made here a Git repository called Terraform MCP demo. In that is a README file which was generated by GitHub. It's basically empty except for the title of the repository. And then I've added to it this VS Code folder, which is green, it's not checked in. And then I have a JSON file here that's configuring my MCP. I should mention that I'm going to use the Terraform MCP server, but There's also a Vault MCP server, and there's a Vault Radar MCP server. So they'll obviously expose different functionality within Vault or within Vault Radar, but there are more than the Terraform MCP server. So when we're looking to start working with an agent or with an MCP server, we want to configure that how we're going to run it, and the way we do that is either you can configure your VS Code to have a general configuration, so you can actually edit the config JSON, and you can put the server settings into your kind of whole setup. And if you can then synchronize that between like multiple workstations and do all the normal stuff you can do with VS Code's configuration, or you can configure things on a per workspace setup, and that is probably the way that I've used it most, because if I'm doing something in Terraform, I might want the Terraform MCP server to be running in that particular workspace, but if I'm writing something in Golang, I don't necessarily want to have the Terraform stuff running. So it just allows me to configure that workspace in the way that I want very specifically. And so I'm going to start with, so this is all commented out. Nothing's running at the moment. I have Copilot running, and I've selected Claude Sonnet because that is pretty good at writing Terraform code out of the box. And then we can ask Claude Sonnet to build us a Terraform environment. So what I typically do is say, hey, build me a Terraform code to deploy a 3-node web service on AWS with a load balancer, database backend, and a middleware in between. And Claude Sonnet by itself will make a reasonable stab at that. That's pretty basic. When you start getting slightly more complicated, you're starting to use modules, you're starting to use different, less frequently used providers. What will happen is, as is the way with these things, you'll start getting slight hallucinations. Maybe it'll tell you that there's a provider service that doesn't actually exist, or it'll be using a module that it's made up by just out of thin air because it thinks it should be there. And this is where the MCP server comes in, because what that allows us to do is query the existing providers. It allows us to query publicly available modules, best practices, documentation. There's a whole bunch of stuff. So I've got this quoted out here. If we have a look at this code, I'll show you. So you can run this. So you can generate this code by hitting add server, and it will walk you through the prompt. So it will say, do you want to run it as a command with standard IO, or do you want to run a HTTP one? It'll then prompt you for the command if you're running a Docker command, or the URL if you're running a service. It'll also allow you to add environment variables and pass environment variables in and that sort of thing. I've got this configured here, so I'm not going to run through that wizard. So you can see here I'm defining an array of servers. I've called this one Terraform Podman. Being a good IBM employee, I'm using Podman and not Docker. But if you were to change the Podman to Docker, for example, you would find that it worked in exactly the same way there. So we've got our command is Podman, and then the arguments are I want to run, interactive, delete it when it's finished, pass it an environment variable. The environment variable I'm passing it is my Terraform token, Terraform Enterprise token or Terraform Cloud token, and then the name of the image that I'm running. And that is almost the bare bones. You could get rid of the environment variables and the token and just run it completely without. So you don't actually need. In fact, let's do that. Let's run it without, and then I'll show you with. So that's the bare bones configuration. You could run it with the Docker command. If you have been following developments with, say, Apple containers, you could use the container command. And they're all designed to be ways of running containers that are consistent across with it, so the inputs are exactly the same across those commands. Now from here, if I save that configuration, you'll see that VS Code's added these details here. So it's added a start. So if I wanted to start the container, I can obviously hit start. It's saying it's exposing 34 tools, and there's a little more there. So let's have a little explore of what's being provided. So if I click on the tools for my AI interactions, I can scroll down and find my Terraform Podman group, and then we can see what's actually being exposed. So attaching a variable set to workspaces, create a run. So these are all tools to interact with either Terraform Enterprise or HCP. So Terraform in the cloud. We also have get latest. So these would be the resources. And so because we're retrieving information, it's a resource. We're retrieving, for example, the latest module version, providers, details for those. We can also get things like the modules and private modules. But much of this is relating to your enterprise or HCP environment. So what I'm going to do is revert my configuration back so that I can input an API key so that we can see some of this working. So here I've got my Terraform token, and that is all configured. I've saved that, so I can run that. And then, just so I'm not lying, we can have a look at Podman, and we can see that we have that container. Oops, clearing the wrong thing. Try that again. So we've got that container created 18 seconds ago. So my MCP server is running. Really simple. It's small, it's lightweight. There's no real harm in like thousands of developers all using that container on their laptops. Generally, if you don't have any requirement for being able to provide a limited scope to your MCP server, then you could just run that. If you're using Terraform open source, or well, not Terraform community, apologies, don't want to poke that sore spot. Terraform community, you can still pull down the latest modules that are publicly available. You can get all your best practices. It's all baked into that information within your Terraform MCP server. Now, so I have this now running. I have input a token to my HCP environment. Where is that? He says. So I have a workspace configured here called Terraform HCP demo, but you can see it's completely empty. It's got my README file. It doesn't have any variables. It doesn't have anything there. There are no runs. There's nothing. It's blank. It was literally created this morning or a day ago. So now if we go in and we ask Claude to build us, someone give me a shout out. Give me something to build that's maybe a little bit more obscure than, say, 3-server AWS front end.
Snowflake database, I don't know, with 3 roles in it.
A Snowflake database with 3 nodes in it. Okay. So, sorry?
3 roles, not node, but roles.
3 roles. Okay. So, create the Terraform code for a Snowflake database with 3 roles. Anything else? Any more complexity? Create users. Create. Okay, so we'll need to be a bit more specific. Create users for each of the roles.
Through Vault.
Hmm?
Through Vault.
Through Vault.
Yeah, Vault has
Okay. Now that might be stretching the complexity just that one bit more, especially as I don't have the Vault MCP server running, and I don't fancy setting it up right now. However, that would be good. I was trying to keep it simple in the scope of Terraform. Okay, any more complexity anyone want to add? Well, let's see what we get from this. So you'll be familiar with how Copilot starts working. It'll tell you what it's going to do. It's going to start making a list of tasks that it's going to go through. And let's just give it a bit more retail here. So what will happen is you can see here that it's actually talking, it's saying, right, get the latest provider version. And so what we can see is it's communicating with my Podman MCP server, and it's found the latest provider from Snowflake Labs. It's version 1.0.5, and then it's having a look at that, and it's saying, okay, what resources are available there, and then it's asking me, do I want to allow it to do this? Now, what I'm going to say here is I'm going to say allow tools from the MCP server without review in this session, because I don't want to click allow, and we'll let it process and we can talk through what it's happening. But this gives you control over what it's asking your MCP server to do. So if you remember that your MCP server is running in a context, if that context is privileged, you don't just want to let it go, you want to review it and have a look at what's happening before you kind of let it just go and blow up production. So we'll allow those for this session. So it's going out and getting the provider capabilities. It's having a look, and then it's starting to identify documentation. It's going to process. All of this is calls it's making to my MCP server. And if you want to get really nerdy, you can, I can't remember what the logs command is in Podman, is it? Podman log. Yeah. And then I'll give it the container ID, and we should be able to see that. So you can see that it's talking to documentation, and we can see that the MCP server is actually going out and doing what we're asking it to do. And Claude has come back. It's creating structure. It's creating the variables, outputs. It's creating all my example files. It's creating a README to start documenting the code. And we can actually start reviewing what it's been doing. So it's started populating the README. It's creating these 3 roles that you've asked for. It's creating 3 users. It's done sort of prerequisite documentation. It's got a bunch of variables. And then it's got the main provider. Now, what will happen is if you leave it as is, it will probably just keep building a bigger and bigger and bigger file with your main TF file, which is perhaps not the most efficient way to work once you start scaling up your Terraform code, as probably most of you have experienced. So if I say keep on this, one of the ways that we can control how the MCP works is by providing it with a set of instructions. So with an LLM, you can provide it with context instructions and ask it to do specific things or to do things in a certain order. And so one of the ways you can start to control how this MCP and LLM are working together is by creating a set of custom instructions. And so I'm not going to write out a set of instructions right now because it'll take a while, but there is on the MCP, the Terraform MCP server, there is some basic instructions to start working with. And if you kind of scroll through, it starts telling you, okay, this is what your capabilities are. This is how you start working. You can get latest provider versions and module versions, and it gives it a process and a structure to the way that it is going about the tasks. And eventually you'll get down to the end and it will say structure it this way, organize your code, split it into larger configurations, use different naming conventions. And all of this is like a bootstrap kind of set of instructions. You can actually go in and say, actually, when I want you to write code, I want you to do it in a certain way. And so you can give it instructions in sort of your language that it will understand. And eventually, this is quite long, but you basically get these Copilot instructions. Now, again, you can put these in various places within Visual Studio Code. I am going to put these for my workspace, so I'm going to create a new folder called .github, and then within that folder I'm going to create a new file, and I'm going to call it, what am I going to call it? Copilot instructions. .md. Okay, so I've created my instructions. I have not pasted in. I will paste in my instructions. Okay, but unless you know this context and you know what's been written, it's a little bit more difficult to understand what the actual changes are going to be happening. So let's make something really obvious. Okay, so in its basic agent instructions, we're going to say you will always speak like a pirate. So we're giving it really specific instructions. It's going to speak like a pirate. And then once we've saved that file, you can either restart your context or you can say reload the Copilot. If I could type, Copilot instructions file. And so hopefully it will do that.
Could you also change that to Yodish, so the language that Yoda speaks?
You could probably do so, yeah. Anything that the LLM will do. But here we go. It's now saying it's now talking in pirate, which is amusing but not so easy to work with. So that is one of the ways that we can then configure that. So now I've got an existing repository of code that has been created, but I want it to start using those instructions and have a look at the code and say, does it match with your instructions? So here I can say, please review the code with the new instructions. And it will go in pirate. That's going to get old quick. It's having a look, it's rereading in all of the configuration that it's previously written, and then it's going to start making modifications based on the instructions that it's been given. So for example, it's noticed that we don't have the file structure in the way that's required, we don't have the backend configuration as it should be, so it's now starting to reconfigure, which is nice. So all of this is happening without really any use of that Terraform key, the token that I put in. But if we wanted to have a look at, say, making some changes within my HCP environment, we could ask, first of all, you can have a look at the functions that are available. So we can create variable sets, we can create workspaces and tags. So let's say, can you list the workspaces available. And it will go out and it will query based on the context of the token that I've given them. It's listing the Terraform organizations. It's telling me what it's doing. And then it's found 3 workspaces. And it's giving you a little bit of information on those 3 workspaces. But it'll also tell you that the Terraform MCP demo is the one that it's configured to use at the moment. And the reason is because of the context of the token that I've given it. So let's make some changes. Let's please add variables for this code. I might need to tell it to the workspace, but no, to the workspace it's doing it. So now it's making another change. It's doing something different, and I haven't allowed that specific action. So now it's saying, am I actually allowed to do this? So I'm going to say again, I'm going to allow it for this session. So it's reading the variables file, and it's going out and creating for me the variables. Now, working like this with the LLM and the MCP server, you can very, very quickly either assume control of an existing repository of Terraform code, understand it, get it to explain it to you, upgrade it to best practices, upgrade it to latest versions, and make sure everything is running according as you would expect, just simply with a few prompts. And as long as you're on top of approving those prompts, it's going to tell you what it's going to do, it's going to give you information, and you can either say yes or no, I want you to do that. Okay, so we have created our variables, so let's go and have a look at the variables page, he said. And there we go. So we have the variables that it's generated for the Snowflake database, which I couldn't have possibly known about before because it came from, it's like a magician's trick, isn't it? I couldn't possibly had it up my sleeve, couldn't pre-bake this. Those variables are in. They are a little bit short for that, yeah. Okay. So that's a little bit about how you can run on locally. I will also show you this MCP JSON. So here is exactly the same thing, running in Docker, running in the Mac container, running in Podman. This one here is running on Kubernetes. So this is a HTTP type rather than the standard I/O. And within the context of that Kubernetes deployment, I've already given it a Terraform token. So that service that is running in my lab at home in the UK is actually authorized to do certain things in a certain context. And as I mentioned, slightly preempting before, the reason you would want to do that is if you have a team of people developing stuff and you don't want to permit each one of those developers to have a local MCP server with a local authentication token to a particular production environment or a protected environment, you want to have everything gatekept through your MCP server. You can stick your OAuth or your tokens through there, and then you can protect it in that way. And that gives you the opportunity to have multiple clients hitting one server. You can also have that with authenticating to whatever different authentication system that's then using a context token. So let's go and if I have a look here. So here we got, this is my Kubernetes cluster, which is 4 Raspberry Pis. Yes. And then within this, we have, in fact, so within this Terraform MCP namespace I've provided, I've got 3 Terraform MCP servers running. I've got a load balancer in front of them, and then I have OAuth authentication happening configured in the front of that load balancer. And that allows me to, I think I actually used my Google account, my Hashicorp Google account, to provide OAuth authentication to access my load-balanced MCP server. And that's also been published as DNS, and there's a Let's Encrypt SSL certificate sitting in front of it. So you can treat it as a completely separate standalone service that then can be hit by multiple people. And then there's configuration variables, so you can have it run sticky sessions, and so when you're having context, you're going backwards and forwards with the same pod, or you can configure it to have stateless sessions effectively, so the context is dropped every time and it re-establishes the context. There are different arguments around why you should do that and you shouldn't. But that's another way of running the Kubernetes, the MCP server in Kubernetes. So,
Where did you get the Kubernetes service you're running? Is that something that Hashicorp provides, or you built it yourself?
so the one that's running on there, I built as a wonderfully curated, handcrafted service that I wrote myself. However, one of the things that I wanted to also show today is that I'm also publishing a unsupported, as is, not officially maintained set of Helm charts where you can start deploying your own Hashicorp MCP servers. And within there, you can actually deploy the Terraform one by itself. You can deploy the Vault one by itself, or you can deploy a single service in front of both and then use like a URL redirect. But it's just as an example of how you could run it if you would so desire. And that's basically because I was learning the MCP server. I do a lot of Kubernetes stuff. I wanted to figure stuff out. So that is available on my GitHub. So that's my name and then Hashicorp MCP servers Helm. But as it says at the top here, provided as is and not officially maintained by Hashicorp. So use it as your own peril.
So Sam, question. MCP is relatively new.
Yep.
What are some of the challenges you've seen when implementing this, or do you see challenges with MCP at all?
What in a sort of more broader context?
Yeah.
Well, I think I'm relatively new to MCP servers also, so I'm caveat with I'm just learning. In what I've seen so far, it seems like a reasonable standard that has been sort of made open by Anthropic, and there are a lot of people adopting it. That said, it's not mandatory to adopt it. It's not you don't necessarily not all of the LLM models will support agents. So agents seem to be the tide, the way things are going. MCP servers seem to be the tide, the way things are going. But AI is still like this big bubbling cloud of nebulous stuff, and it's not yet settled that MCP will be the way that things talk to each other. So if there's any kind of worry there and concern there, is that it may something new might come out in a month's time that's the new way of doing it, and it might supersede MCP. But for now, that seems to me the easy way to access.
Yeah. First, very nice shirt.
Thank you.
Very beautiful. The second thing is, what's the major difference between using like some agent, like client, bot, or copilot in agent mode, and running specific MCP servers for each of the tools or whatever we want to do? What's the major difference between using both of them?
I guess it's the way that you're using them. It's how it fits into your workflow. You don't want to provide. To me, it would be how you're using it, how you're working it into your workflow. don't have any more specific answer than that. What are your thoughts on that? Is there?
Yeah, because for instance, I use Klein, and with Klein I can plug any LLM I want,
Yeah.
and Klein has the plan and the act mode. When I am running in the plan mode, I can give all the instructions and context, and it will generate the plan for me. When I switch to the act mode, it will create very workable solutions in most of the times, and I don't have to configure anything else. I just have to give the proper context, and everything will work. So I'm trying to understand what's what exactly I'm gaining if I am using an MCP server for Terraform, one for Vault, one for AWS.
Yeah. So the MCP server will provide you with more accurate answers than you'll get from a generic set of queries. So you can put a simple request into Claude or any of the LLMs, and it will give you a reasonable effort. And a simple deployment, a simple set of instructions is fine. Once you start importing a big code base into it, so managing hundreds or thousands of different objects and maybe some more eccentric ones, so you're not using just sort of like a AWS provider, but you're going off and you're using something a little bit more less mainstream, less likely to be in an LLM's kind of learning data set. You'll find that there are things that are either not done correctly or missed, or you have basically the hallucination problem where you have modules that are created out of thin air, but the modules don't exist. So I'll give you an example. I was using Claude to refactor an application we have internally. So we have a chatbot which we use to log our work. So internally, we log our work. We're measured on a certain number of hours we influence, so we log these things on this chatbot. And the infrastructure for that was managed by Terraform, and we were kind of like using our own tools to make sure that we were. That's annoying me. Using our own tools to make sure that we were, dog fooding our own stuff. But the problem is that the person who had created this Terraform had left long before I joined the company, and it had been going along fine, and then it started to have problems, things started falling over. So my boss asked me, can you look at it? We need to get it stable. We need to reduce the cost because it was built way too big and all sorts of things. So I'm looking at it, and I start asking Claude to refactor things for me, to change things. And it starts with some helpful stuff, very quickly descends into the point where it's referencing things that don't exist. It's creating names for things that didn't exist, having that hallucination problem. It was fine with like your standard AWS EC2 instances because there's plenty of reference material kind of out there that it was trained on. But the more specific stuff and the best practice stuff were baked into the Terraform MCP server, and they're not there in the generic stuff. So hopefully that answers a little bit more clearly. I feel like I waffled a lot there and got distracted by my laptop, but does that answer your question?
Yeah, no, yeah. I think what I am getting here is that with the MCP, we are able to teach the LLM more skills or more precise ways of working, right?
Yeah, it's the precision, but also it's being able to reference documentation. The MCP server knows exactly how to access the most up-to-date list of providers and modules that's available in the public registries, but also if you're using enterprise or HCP, it's referencing your private ones as well. So if your company's built a private module for a specific internal API, the MCP server can reference that module, look at the documentation that's on your registry, and teach the LLM how to write for that. So it's accuracy, but it's also the ability to look up the most current information.
Okay, perfect. Thank you.
Let me just add one thing about the MCP. Like, one of the biggest differences is really what he said. Like, when you start working, like maybe Terraform it will be good answers, but I work a lot with Nomad, for example. If you start to ask questions for ChatGPT or Cloud by Nomad, it will simply create something out of his head, and it will not work. It simply thinks, yeah, you should use whatever function that never exists. So when you have the MCP, it's sort of like references the documentation, and it's sort of, let's say, a specialist AI that will give you more accurate results. It doesn't mean that it will not give you wrong results, but it's less likely that you will spend more time on it, I would say.
I actually was trying to use the MCP server for Terraform a little while ago. So I'm not sure if my experience still is relevant or is it fixed, but something that I ran into was that, well, of course, one of the tools is get the documentation for a module or a provider, and sometimes the information that was returned by the MCP tool was too long to be processed with the LLM. So I would like to ask if this is something that you recently ran into, and if you know if there is a workaround for that. Apart from, the documentation is written by third parties, and that has probably need to be adapted to like an AI-friendly format. But yeah.
It's not something that I've run into, and I mean I have been experimenting with trying to use the MCP server with the smallest models and the least capable models that I can. So I'm running like LM Studio on my laptop with as smaller models, models as possibly can, and I haven't run into the problem where it's run out of context. So I don't know when that was. Maybe some of the earlier versions or.
I think it is. I'm not sure it is the exact one that you showed here that's running. The version seems to be the same, what I have from back then and what you're showing today. But I basically have an executable, not the container. And for the MCP tools, I noticed that I have a few tools versus what you showed was, I think, 30-something tools. So there's definitely a difference, but I don't exactly know where.
Yeah, so I know at Hashicorp we kind of announced the MCP server stuff. I know that it's been actively developed. I couldn't tell you what the difference between the point versions is at the moment. If you run into it again, like feel free to you can ping me and I can feed it into the product team because. He's been quite helpful. The product managers for it's been helping me with various things. So I've got a good channel into him. So yeah, if it's something that you kind of continue to see, for sure, let me know, and I'll do my best to figure out an answer.
Yeah, thanks.
All right. Do we have any more questions? Anyone? Comments? Anyone want to throw something? Not you two.
Are you aware of any future MCP servers that are going to come out of Hashicorp in the near future?
I am not aware of any new ones. That I would imagine that the team working on the MCP service is focusing on the core products around Terraform Vault, but probably in the order of scale of the products that are being used. I would have guessed. Don't quote me on that. Cool. Okay, well, thank you for your time today and for listening to me, and I hope you got something out of that.